Ever wondered why supply chain optimization is such a challenge in today's globalized world? It's because modern supply chains are incredibly complex, spanning multiple countries and involving numerous stakeholders. They are riddled with unpredictable variables, from fluctuating demand and supply to the ever-evolving global trade policies. Tackling these challenges requires more than traditional methods. It requires innovative and advanced solutions that can handle this complexity and unpredictability. Enter quantum-based optimization, a groundbreaking approach that leverages the principles of quantum physics to enhance supply chain efficiency. The backbone of this approach is the McGinty Equation, a mathematical model that describes the behavior of quantum fields. It provides a robust framework to model and optimize complex systems such as supply chains. So, as daunting as these challenges might seem, they're not insurmountable. The solution to these challenges lies in an unexpected field: quantum physics, and more specifically, the McGinty Equation. What if we told you that a quantum physics equation could be the key to optimizing your supply chain? Now, don't panic. We're not about to dive into a complex physics lecture. We're here to break down the McGinty Equation in a way that's easy to understand. So let's start with the basics. The McGinty Equation, or MEQ, looks like this: Piece xt equals sign Piece QFT xt plus PS fractal xt dmqs. Now that may seem like a mouthful, but let's break it down piece by piece. First, we have Piece xt. This represents the state of your supply chain at any given time and location. It's a dynamic variable that changes as your supply chain evolves. Next, we have PSQFT xt. This is the solution of the free quantum field theory, which in our context represents the natural, undisturbed state of your supply chain. It's the ideal scenario where everything runs perfectly without any external influences. Then we have PSFractal XTDMQS. This term represents the complexities of your supply chain, using a concept from fractal mathematics. Fractals are shapes that are infinitely complex, much like your supply chain with its myriad of interconnected parts and variables. The variables D, M, Q, and S in this term represent different aspects of your supply chain, like demand, manufacturing capacity, quality control, and speed of delivery. By adding these two terms together, the McGinty Equation provides a holistic picture of your supply chain. It captures both the ideal state and the real-world complexities, and it gives us a mathematical framework to understand and optimize your supply chain. But how exactly does this help you? Well, by using this equation, we can model different scenarios, predict outcomes, and find the optimal strategies for your supply chain. Whether it's reducing costs, increasing efficiency, or improving delivery times, the McGinty Equation can guide the way. In essence, this equation holds the potential to revolutionize the way we understand and manage supply chains. But the magic doesn't stop there. The McGinty Equation has been further modified to account for the effects of gravity. Imagine you're taking the McGinty Equation for a spin. Our journey begins with the free quantum field theory solution, PSQFT-XTT. This part of our equation journey remains untouched. Next, we come to the PSFractal XTDMQS section. This is where things get a little tricky, but bear with me. It's all about fractal structures, self-similarity, and constant parameters, V0, L, and S. These are the building blocks of our equation's fractal potential term, VYT. But let's not get too comfortable, because here comes the twist. The equation has been enhanced with an additional term, gravity, XTG. This new component represents the perturbative effects of gravity on the quantum field. Gravity, as we know, is a fundamental force that influences everything, even our quantum field. Here, G is a parameter that characterizes the strength of the gravitational force. This modification to the McGinty Equation is like adding an extra gear to a well-oiled machine, giving it the ability to account for the effects of gravity. It's a bit like adding a secret ingredient to your favorite recipe, taking it from good to unforgettable. This modified McGinty Equation thus becomes a more comprehensive tool, enabling us to make even more accurate predictions. It's like having a map that not only shows you the roads, but also the hills and valleys you'll encounter on your journey. In the realm of supply chain optimization, this translates to even higher efficiency, reduced costs, and increased productivity. It's like having a secret weapon in your arsenal, ready to tackle any challenges that come your way. So, there you have it. The modified McGinty equation, equal parts fascinating and formidable. It's like a complex symphony where every note is essential for the overall harmony. This modification adds another layer of sophistication to the equation, allowing for even more accurate predictions and optimizations. So, what does all this mean for supply chain optimization? Well, let's roll back the tape and revisit the key points we've covered. We began by acknowledging the complex challenge of supply chain optimization. We're talking about numerous variables, unpredictable factors, and the constant pressure to reduce costs while increasing productivity. It's not just a puzzle, it's a constantly shifting, multi-dimensional puzzle. Then we introduced you to the McGinty Equation. This is a quantum field theory that offers a new way of looking at complex systems. The equation in its simplest form is a blend of the free quantum field theory and mechanical systems. But, as with all things quantum, it's not that simple. The equation also includes a fractal potential term with a self-similar fractal structure. We then dive deeper into the modified McGinty equation. Here we added an extra layer, the perturbative effects of gravity on the quantum field. This addition not only adds complexity, but also a new level of accuracy to the equation. So how does all this quantum and fractal talk help with supply chain optimization? Well, these equations provide a new way to model and predict complex systems. They allow us to see the supply chain not as a static entity, but as a dynamic, constantly changing system. This approach can help identify potential bottlenecks, predict demand fluctuations, and optimize routes and resources. We're not saying this is a silver bullet. Supply chain optimization is a complex challenge that requires a multifaceted approach. But the McGinty equations offer a fresh, innovative perspective. They provide a new tool to add to the toolbox of supply chain professionals. And that's where quantum physics comes in. It's not just about particles and waves, it's about using these principles to solve real-world problems. Quantum physics and the McGinty equation offer a new approach to supply chain optimization, promising to transform logistics and manufacturing efficiency for the better.